everyone, I am Pavitra. Welcome to my brand new channel. This is my first video and in this video we shall discuss Floyd Warshall Algorithm. Floyd Warshall Algorithm is an algorithm for finding the shortest paths in the directed weighted graph with positive or negative edge weights but with no negative cycles. Thus, the algorithm fails whenever there is a negative cycle in the network. The directed weighted graphs are the graphs that are made up of set of vertices connected by directed edges and weights or values assigned to their edges. Now let us look into the history behind this. This algorithm is an example of dynamic programming and was first published in its currently recognized form by Robert Floyd in 1962. However, it is essentially the same as algorithm previously published by Bernard Roy in 1959 and also by Floyd Warshall in 1962. All these three scientists worked independently. Sometimes this algorithm is also referred as Floyd-Roy or Floyd Warshall algorithm. Now we shall discuss the algorithm. For a given network, develop an n cross n matrix where n is the number of vertices, and since there will be no loops, the diagonal elements are kept empty. The ijth cell of the matrix is entered the value of dij, denoting the distance between vertex I and vertex j if there is an edge between I and j. And if there is no edge between I and j, the dij is kept infinity initially. Draw the n cross n distance matrix dk and draw the vertex sequence matrix sk. Initially, dk is kept as d0 and sk is kept s0. General steps we need to follow for k is equal to 1 to n are: set k is equal to 1, consider row k and column k as pivot row and pivot column. We have one condition to be checked and proceed accordingly. That is, for each cell value dij in distance matrix of dk minus 1 for all I and j, if dik plus dkj is less than dij or not. Note that this dij is obtained by the previously computed distance matrix. Where I is not equal to k and j is not equal to k, then create dk by replacing dij of dk minus 1 with the value that is obtained dik plus dkj, and create sk by replacing sij in sk minus 1 with k if this condition is satisfied. Else, we need to write down the same value which is previously obtained if it is not satisfied. Set k is equal to k plus 1 and perform the iteration, and we shall stop when k is equal to n plus 1. Now let us see an example where this algorithm can be applied. Suppose in the famous cartoon series Chota Bheem, Chutki has invited her friends Bheem, Raju and Jaggu to her home for Laddu party. Bheem lives 5 km away from Chutki's home, 3 km away from Jaggu's home and 2 km away from Raju's home. Whereas Jaggu and Raju live 4 km and 2 km away from Chutki's home respectively. Now let us try to find out the shortest path from each of them to reach the party. Now we shall draw the network using the given conditions. An edge between Bheem and Jaggu is placed representing the distance between them, that is 3. The distance between Bheem and Raju is 2. The distance between Bheem and Chutki is 5. The distance between Jaggu and Chutki is 4. The distance between Raju and Chutki is 2. The solution of the given problem starts by initializing k is equal to 0 and by constructing the distance matrix and vertex sequence matrix, that is D0 and S0. For our convenience, let us consider Beam to be vertex 1, Chakku to be vertex 2, Raju to be vertex 3, Chutki to be vertex 4. If there is a directed edge between two nodes, then the corresponding distance value is entered as a cell value in distance matrix. If there is no directed edge between two nodes, the value of the cell remains infinity. Vertex sequence matrix is considered by entering all the first column as 1, second column as 2, third column as 3 and fourth column as 4. This is, we assume the directed path itself is the shortest path. Now consider k is equal to 1, and for this we shall compute D1 distance matrix and S1 vertex sequence matrix. For this, the first row and the first column are fixed, and we shall compute the cell values which are remaining. To compute D1, we shall check whether Dik plus Dkj is less than Dij or not. This Dij is obtained from D0 matrix, and this we shall compute now. For I is equal to 2 and j is equal to 3, the D21 plus D13, that is 5, is obtained to be less than infinity, that is in the D0 matrix. When I is equal to 2 and j is equal to 4, 8 is obtained, which is greater than 4. For I is equal to 3 and j is equal to 2, we obtain 5, which is less than infinity. Similarly, when I is equal to 3 and j is equal to 4, we obtain 7, which is greater than 2. For I is equal to 4 and j is equal to 2, we obtain 8, which is greater than 4. For I is equal to 4 and j is equal to 3, we obtain 7, which is greater than. We have obtained that the two cells, that is D23 and D32, satisfied the condition. Thus, we shall replace these cells with 5 and we obtain the modified D1 matrix to be 5 in place of infinity, and here too is 5 in place of infinity. Corresponding k value is equal to 1 is entered in Sij to be 1, and here also 1. The remaining values remain as it is. Now we shall compute for k is equal to 2 by keeping the second row and second column fixed and computing the rest of the values. You can pause the video and compute yourself and check whether any of the cell values change or not. We see that none of the values have changed. Thus, the D2 matrix which we obtain is same as D1 distance matrix, and S2 matrix also is same as S1 matrix. Now we shall compute for k is equal to 3 by keeping the third row and third column fixed and compute the rest of the values. we see that the value of di4 and d41 has changed, and the cell values have got the value 4 and 4, and the corresponding k is equal to 3 is entered here in the vertex sequence matrix. The final matrix for k is equal to 3 is this. Now we shall compute our last iteration, that is k is equal to 4, by fixing the 4th row and 4th column fixed, and compute the rest of the values. The solution we are looking is this matrix, that is D4 matrix and vertex sequence matrix S4. The interpretations we can get from this matrix is the node 4, that is Chutki's home, and the node 1, which is representing Beam's home. The shortest distance between these two nodes is 4, and the corresponding vertex sequence matrix tells whether there is a directed graph which is the shortest distance or not. Here you can observe that in S41 the value instead of 1 it is 3, meaning that the person who is traveling needs to visit vertex 3 and then visit vertex 1. To conclude, we have the shortest distance between Beam and Jaggu to be 3. The shortest distance between Beam and Raju is 2. The shortest distance between Jaggu and Raju is 5. The shortest distance between Jaggu and Chutki is 4. Between Raju and Chutki is 2. And finally, the distance which is shortest for Beam to reach Chutki's home is through node 3, that is Raju's home first, and the length is 4. And that's it. Thank you for watching. Hope you got to know how to solve the shortest distance problem using Floyd Warshall algorithm. If you enjoyed watching this, then like, share, subscribe, and always think like a child and never let the curiosity to fade away. Thank you all. Have a great time. Bye bye.